Hi, hello my dear students, a very good evening to all of you. So warm welcome to Master School Foundation program. Now we are discussing in the chapter functions, types of functions. Already we started that. In the previous class we discussed the even function, the identity function and the constant function, like that. So today we are going to discuss some more types of functions. So remember, all these definitions are most important. So we can use these definitions in the remaining chapters also. So that's why these concepts are the basics for the remaining chapters. So if you are not if you are not following regularly, then you are not able to understand the problems or concept related to these concepts. Okay. Now in types of functions, next we are going to discuss some more types of functions. In the last class we discussed identity function, constant function and even function, and we discussed the graphs and properties of those functions. Okay. Now let us start the class today. So functions is the chapter name. Here we have let f maps. Already we have completed this in the last class. Next all the types of functions. So constant function is completed. So next, so identity function, this is also completed in the last class, and we discussed the graph of the example and graph of the identity function. So next, so already we discussed the even function also. So next, already we discussed the graph of even function also. So today we are going to discuss the odd function. So still now we have discussed, so that's why we have I have recapped them. So identity function, constant function and even function. So today we are going to discuss the odd function. In last class we discussed what the even function is. If we suppose that R is the set of real numbers and if A is any subset of capital R, then the function f maps A to R is said to be an even function if f of minus x equal to f of x. In the given function, in place of x, by writing minus x, you will not get any change. In the given function, in place of x, by writing minus x, you will not get any change. So then we can say that is an even function. If we take f of x equal to x square, in place of x by writing minus x, you will get f of minus x equal to minus x whole square equal to x square. So we can say the function f of x equal to x square is an even function. In the given function, in place of x by writing minus x, the function will not be changed. Those type of functions are known as even functions. Odd function means just we have to take the opposite definition of that. Here also let us suppose that A is any subset of capital R is the set of real numbers. Now the function f maps A to R is said to be an odd function if f of minus x equal to minus f of x for all x belongs to A. So let us suppose that y equal to x cube, y is nothing but f of x. So f of x equal to x cube. So sometimes we can denote the function f of x by y. So if you take the function f of x as x cube, according to the definition, in place of x by writing minus x, we have to get minus x. So in place of x by writing minus x, f of minus x equal to minus x whole cube. Here the power of minus x is 3. So that is an odd number. Minus 1 power odd number is always minus. Minus 1 power even number is always positive. So minus 1 power odd number negative. So that's why minus x into minus x into minus x, you will get minus x cube. So that is minus. According to the problem, x cube is given as f of x. So in place of x by writing minus x, we have gotten minus f of x. So that's why we can say the function f of x equal to x cube or y equal to x cube is an odd function, is an odd function. So let us suppose that A is any subset of capital R is the set of all real numbers, R is the set of all real numbers. Now the function f maps A to R, now the function f maps A to R is said to be an odd function if f of minus x equal to minus f of x for all x belongs to A. If we suppose the function is f of x equal to x cube or f of x equal to 3x power 7, f of x equal to x cube or f of x equal to 3x power 7, in place of x by writing minus x, in place of x by writing minus x we are getting minus f of x. If we take y equal to x cube, y is nothing but f of x equal to x cube, in place of x by writing minus x, f of minus x equal to minus x whole cube. So that is minus x into minus x into minus x cube. X cube is nothing but f of x. So we have gotten f of minus x equal to minus f of x. So we can say the function f of x is an odd function. So clearly if you take y equal to 3x power 7, in place of x if you take minus x, f of minus x equal to 3 into minus x power 7. So again the power 7 is an odd number. So minus 1 power odd number is minus. So you will get again minus 3x power 7, that is minus f of x. So we can say this is also an odd function. So odd function definition means if we suppose that R is the set of all real numbers and A is any subset of capital R. If we take a function f from A to R, if we define that function as f of minus x equal to minus f of x for all x belongs to A, then we can say the function is an odd function. So let us take the example f of x equal to x cube, f of x equal to 3x power 7, f of x equal to x power 11, like that. So those functions are known as odd functions. Now let us discuss the graph of the odd function. So the graph of odd function is symmetric about origin, means with respect to the origin the graph of odd function lies in the opposite quadrants, lies in the opposite quadrants. So first and third or second and fourth, like that. So with respect to the even function we can say the graph of an even function is symmetric about x-axis. Here the graph of x-axis is symmetric about the origin. Symmetric about the origin means with respect to the origin the curve will be lie in the opposite quadrant. So first quadrant, third quadrant or second quadrant or fourth quadrant, like that. So if you take the graph of even function, so here some functions are neither even nor odd functions. So according to the definition of even function, f of minus x equal to f of x, in place of x in the given function by writing minus x there will no change, then we can say that is an even function. In the given function in place of x by writing minus x, if we get minus f of x, so means f of minus x equal to minus f of x, then we can say that is an odd function. But sometimes in the given function in place of x by writing minus x, you will not get either f of x or minus f of x. Those functions are known as neither even nor odd functions. If you suppose that f of x equal to x square plus x power 5, f of x equal to x square plus x power 5, in place of x if you write minus x, f of minus x equal to minus x whole square plus minus x power 5. Minus x whole square means x square, minus x power 5 means x power 5. But according to the problem, x square plus x power 5 is given as f of x. So this is neither f of x nor minus f of x. So this is neither f of x nor minus f of x. So we can say the function x square plus x power 5 is neither even nor odd function. The function x square plus x power 5 is neither even nor odd function. So f of x equal to x square plus x power 5 is given. In place of x by writing minus x, we are getting x square minus x power 5. So we are not getting either f of x nor minus f of x. So that's why we can say the function x square plus x power 5 is neither even nor odd function. Now let us discuss the graph of the odd function. Let us take, so this is x-axis, so this is the red line, and let us take this red line is y-axis. Now we know the intersecting point of x-axis and y-axis is origin. Now, if we take the graph of odd function, you will get the graph like this. So, for example, if you take y equal to x cube or f of x equal to x cube, in place of x if we take minus 1 whole cube is minus 1. So, x equal to minus 1, y equal to minus 1. If you take x equal to minus 2, so minus 2 whole cube minus 8, x equal to minus 2, y equal to minus 8. Next, if you take x equal to 0, y is also 0. If you take x equal to 1, y equal to 1 cube 1. If you take x equal to 2, y equal to 8 like that. So, you will get the graph of odd function like this. By observing this graph clearly, we can say the graph of odd function is symmetric about the origin. Symmetric about the origin means with respect to the origin, the graph of odd function lies in the opposite direction 1, 3 or you may have 2, 4. So, the graph of odd function is symmetric about the origin. So, this is the graph of the odd function. So, even function and odd function, here we can do the same procedure. So, what the procedure? In the given function in place of x we have to write minus x. So, first of all we have to take the given function as f of x. So, first of all we have to take the given function as f of x in place of x by writing minus x, means f of minus x. After simplification, if we get f of x, we can say f of x is an even function. After simplification, if we get minus f of x, then we can say f of x is an odd function. But for some functions in place of x by writing minus x, we are not getting either plus f of x or minus f of x. So, these type of functions are known as neither even nor odd functions. Okay. If you take the graph of odd function by considering some values of x equal to minus 3, minus 2, minus 1, 0, 1, 2, 3 like that, and if you suppose that the function is f of x equal to x cube, after simplification you will get the values of f of x. Take the values of x on x axis and take the values of y, values of f of x on y axis, and by drawing a graph you will get the curve like this. So, with respect to this graph we can say the graph of an odd function lies in the opposite direction, means that is symmetric about the origin. So, take the concept of odd function as a screenshot. So, by taking the screenshot of this slide you will get the concept of odd function. So, take the screenshot. Next, take the screenshot of graph also. So, by observing the graphs of even function and odd function. So, we can say the graph of even function is symmetric about x axis, and here by observing the graph of odd function, this is symmetric about the origin. Next, let us discuss the next modulus function or absolute value function. So, this is the most important definition. We can use modulus in the remaining chapters also, in the remaining subjects also. So, first let us discuss what is the modulus. Here if we suppose that x is any real number, then the modulus of x is denoted by like this. So, take x and take two lines on both sides of x. So, x is the real number. By taking two lines on both sides of x, you will get some expression. That expression is known as representation of modulus of x. So, this can be read as modulus of x. So, this can be read as modulus of x. If x is any real number, then the modulus of x is denoted by like this and defined as follows. Here mod x equal to minus x if x less than 0, mod x equal to 0 if x equal to 0, mod x equal to x if x less than 0. Three cases are there. When x less than 0, negative. When x equal to 0, neither negative nor positive. When x greater than 0, so this is not less than 0, so this is greater than 0, not less than, so that is mistake. So, greater than 0, here we have three cases: less than 0, equal to 0 and greater than 0. less than 0, equal to 0 and greater than 0. So modulus of x can be treated as minus x when x less than 0. Modulus of x can be taken as 0 when x equal to 0. Modulus of x can be taken as x when x greater than 0. So x less than 0, negative numbers, x equal to 0. So 0 is non-negative, non-positive number, x greater than 0, that is positive. So modulus of x means in place of x you may have positive number or negative number. In place of x you may have positive number or negative number. We can consider that as positive only. So for example, here according to this, if you take x less than 0, so I am taking minus 2. So modulus of minus 2 equal to, according to the definition, when x less than 0, when x less than 0, we can take minus x. So minus of, in place of x we have minus 2. So minus of minus plus 2. So in place of x, if you take any negative number, so minus 1, minus 2, minus 3, minus 4.5, you may take any negative real number. After simplification, you will get that is positive. Next, if you take exactly 0, so modulus of 0 equal to 0 only. If the value of x is exactly 0, then we can write mod x equal to 0. Mod x equal to 0. Next, if you take x greater than 0, if you suppose that 5, modulus of 5 equal to 5 only. So by observing these three, modulus of minus 2 equal plus 2 positive, modulus of 0 equal to 0, modulus of 5 equal to 5, this is also positive. So what we observe by these two, in place of x by writing negative number or positive number, we are getting the positive number only. In place of x by taking negative number, we are getting plus 2, that is positive. In place of x by taking 5, that is positive. After simplification, we are getting 5 only. So whatever the number x may be, that may be either negative number or positive number, modulus of x is always positive. Modulus of x is always positive, but in place of x, if you take 0, modulus of 0 equal to 0. So the modulus of x is either 0 or positive. So clearly we can say modulus of x is greater than or equal to 0. Modulus of x is greater than or equal to 0. So generally we can use the modulus functions while finding the areas of the triangles or quadrilaterals, or finding the length or breadth, like that, because area cannot be negative, length cannot be negative, breadth cannot be negative, volume cannot be negative. So for those type of problems we can take modulus, because while solving the problem sometime we may get the negative value. To make that negative value as positive, we can take the modulus. Modulus is nothing but positive. So for example, find the area of the triangle formed by the points A1, 2, B3, 4, C5, 6, like that. So by using the formula of modulus x1 y1 x1 y2 minus x2 y1 plus x1 y2, by using that formula you will get some value. That value may be either positive or negative. Okay, if the value is positive, no problem. If the value is negative, but area of the triangle cannot be negative. So to make that negative value as positive, then in this case we can take the modulus. So if x is any real number, then the modulus of x is denoted by like this and defined as follows. So modulus of x equal to minus x if x less than 0, equal to 0 if x equal to 0, equal to x if x greater than 0. In place of x, if you take any negative real number, if you take minus 0.8, modulus of minus 0.8, so minus of minus 0.8, again you will get plus 0.8. So in place of x you may take any real number. In place of x you may take any real number, we are getting that as positive only. So modulus of x is always greater than or equal to 0. If x is any real number, modulus of x is always greater than or equal to 0. So that's why we can say modulus of x is positive function. So if x is any real number, then the modulus of x is denoted by like this and defined as follows. Mod x equal to minus x if x less than 0, equal to 0 if x equal to 0, mod x equal to x if x greater than 0. So take the screenshot of this slide. Next. Now, to find the domain and range of a modulus function, the domain of modulus x is capital R. Means in place of x you may take any real number and the range is 0 comma infinity. For infinity we have to take the bracket like this. For infinity and minus infinity always we have to take the open bracket like this, because infinity or minus infinity are unknown values, they are undefined values. So that's why we can take like this. So the domain of mod x is capital R. Domain means the values of x, the values of x. Range means the set of all images of elements of the domain. In place of x you may take either negative real number or positive real number or 0. What we get modulus x is positive only. So that's why in place of x you may take any real number, means the domain of mod x is capital R and the range is 0 comma infinity. In place of x by taking any real number, in place of x by taking either negative real number or positive real number, modulus x is always greater than 0. If you take exactly 0, that is 0. So here in the range of modulus function it is not possible to get the negative values. You may get 0 or more than 0, that is positive. So that's why we can say for the modulus function the domain is capital R and the range is 0 comma infinity. 0 comma infinity. You may get any real number. Here you are not getting the negative real numbers in the range of a modulus function. Finding the range is nothing but finding the values of x. Finding the range means finding the domain means finding the values of x. Finding the range means we have to take the set of all images of all elements of the domain. So the domain of mod x is capital R and the range is 0 comma infinity. Now we can take the graph of mod x. So take the screenshot of this slide. Next, let us discuss the graph of the modulus of x. Here let us take the x-axis and let us take the y-axis like this, and let us take O is the origin, that is nothing but the intersecting point of x-axis and y-axis. Now this is the graph of the modulus function. Now this is the graph of the modulus function. So just like even function, for even function also we have the graph just like this. So here modulus x means that is always positive. So in place of x you may take, here if you suppose that the function is f of x equal to modulus of x, in place of x you may take negative values or positive values. After simplification you will get modulus of x as positive only. So that's why we can take the graph of modulus of x above the x-axis. You will not get the graph of modulus x below the x-axis. Below the x-axis means negative y-axis, but here according to the range of a modulus function the range starts with 0. The range starts with 0 only. You will not get a negative number in the range of modulus function. So that's why the graph of modulus x cannot lie in the negative below the x-axis, means on negative with respect to the negative y-axis. So if you suppose that f of x equal to mod x, in place of x by taking either negative values or positive values you will get positive y values only. So by taking x values on x-axis and by taking y values on, by taking f of x values on y-axis, you will get the graph of modulus function like this. You can take some value -3, -2, -1, 0, 1, 2, 3 like that. Modulus of -3 plus 3, modulus of -2 plus 2, modulus of -1 plus 1, modulus of 0, 0, modulus of 1 plus 1, modulus of 2, 2 like that. You may take any number of values. Consider some negative values and some positive values and 0. So by simplifying you will get the graph of modulus function like this. So this is the graph of the modulus function. So take the screenshot. So next, so properties of modulus function. So modulus function is always positive. So by observing the first property, x square equal to mod x whole square equal to mod x square. If you suppose that x equal to minus 2 whole square is 4. Modulus 2 whole square. Modulus 2 is nothing but 2 only. 2 square equal to 4 mod x square. So in place of x, by taking minus 2 whole square is again 4. So if x is any real number, x square equal to mod x whole square equal to modulus x square. Second property, mod xy equal to modulus of x into y. If you take x equal to 2, y equal to minus 3. If you take x equal to 2, y equal to minus 3. So we can take 2 into minus 3. So 2 into minus 3 is modulus of minus 6. We can take that as positive only. Here modulus x into modulus y. Mod x means modulus of 2 into modulus of y means modulus of minus 3. Mod 2 to modulus of minus 3 3. 2 3 is 6, both are same. So that's why if x comma y are two numbers, they may have positive sign or negative sign or 0. If you take both x and y are zeros, x into y 0 into 0 0, mod 0 into mod 0 0, or one is non-zero number and second one is a 0. So for example, x equal to 2, y equal to 0. So 2 into 0 0, modulus of 0 is 0. Mod 2 into mod 0, again you will get 0. So if x comma y are two real numbers, then modulus of xy can be expressed as mod x into mod y. Next, if you take third one, modulus of x by y equal to mod x by mod y, where y must be not equal to 0. If you take y equal to 0, modulus of x by mod 0. Mod 0 means that is something by 0, you will get infinity, not defined. Whatever the value in numerator may be, but the denominator is 0, then we can't define that value. So something by 0 is infinity, 0 by something is 0. In numerator you may take the value as your wish, but in the denominator if we have 0, then we can say the value of that expression or that fraction is not defined. The value of that expression is not defined. So that's why here y must be not equal to 0. So modulus of x by y equal to mod x by mod y. Modulus of x by y equal to mod x by mod y, where y not equal to 0. So next property, modulus of x less than or equal to a. This can be represented as minus a less than or equal to x less than or equal to a, where a greater than or equal to 0. So a may be positive number or greater than 0. A may be 0 or greater than 0, positive number. If you take modulus of x greater than or equal to a, in this case we can write x less than or equal to minus a and x greater than or equal to a. Here also a greater than or equal to 0. So these are the properties of modulus function. So modulus function means if x is any real number, then the modulus of x is denoted by like this and defined as modulus of x equal to minus x if x less than 0, equal to 0 if x equal to 0, modulus of x equal to x if x greater than 0. So modulus of x means plus or minus x. In place of x you may take either positive real number or negative real number. Modulus of x is always positive. So we have discussed the graph of modulus function. So the graph of modulus x is always above the x-axis. So now by discussing the properties of modulus function, x square equal to mod x whole square equal to mod x square, modulus of xy equal to mod x into mod y, modulus of x by y equal to mod x by mod y, where y not equal 0, mod x less than or equal to a, minus a less than or equal to x less than or equal to a, where a greater than or equal to 0, mod x greater than or equal to a implies x less than or equal to minus a or x greater than or equal to a, where also a greater than or equal to 0. So take the screenshot of this slide, properties of modulus function. So next let us discuss the next function. So greatest integer function. So greatest integer function. So if you suppose that x is any real number, then the largest integer, largest is nothing but greatest. The greatest integer which does not exceed x is called the integral part of x and is denoted by like this. So this is not a normal bracket. That is, we can represent the greatest integer function like this. Greatest integer function also known as step function, both are same, step function. So greatest integer function or step function, both are same. So we can read this as greatest integer of x or integral part of x, or simply we can read that as step x. So if x is any real number, you may take positive real number or negative real number or 0. If x is any real number, then the largest integer, not integers, then the largest integer which does not exceed x. So which does not exceed. So don't take the value of x, exceed x, is called the integral part of x, and that is denoted by like this. If x is any real number, then the largest integer which does not exceed x, which does not exceed x. So we may have so many number of integers greater than x, but among all those we have to take the number largest integer. We have to take the largest integer. So if x belongs to R, then the largest integer which does not exceed x is called the integral part of x and is denoted by like this. So we can read this as integral part of x, or simply we can read that as step x. So we can read this as step x. So don't consider this as normal bracket. Sir, how can we know when the given is step function or just normal bracket? If the given problem is related to step function, clearly they mention where step x represents greatest integer function or largest integer function or step function. So if they mention like this, then only we can say box x, that step x, as greatest integer function. Otherwise we can take this as the normal bracket only. We can take this bracket x as normal bracket only. So in the examination, if the problem is related to greatest integer function or step function, clearly they mention where this represents the greatest integer function. If they do not mention, then we can take that as just normal bracket. If x is any real number, then the largest integer which does not exceed x is called the integral part of x and is denoted by like this, and we can read this as step x. So if you take the example, so if you take x equal to 2.3, if you suppose that x equal to 2.3, then we can write step 2.3 equal to, step 2.3 equal to, here x equal to 2.3. According to the problem, you have to take the largest integer. So for if you take x equal to 2.3, if you take x equal to 2.3, we can take the integral part as 2. So where 2 cannot exceed 2.3. So many integers are there. So if you take 2.3, so if you take so many integers less than 2.3, 1 is less than 2.3, 0 is less than 2.3, minus 1 is less than 2.3. But among all those integers, we have to take the largest integer. So many integers are there less than 2.3. If we take 1, that is less than 2.3. If we take 0, that is less than 2.3. If we take minus 3, that is less than 2.3. If we take minus 10, that is also less than 2.3. But among all those numbers, we have to consider the number. We have to consider the largest integer. So by observing 2.3, step 2.3, so many integers are there less than 2.3, but among all those the largest integer is 2, where 2 is not exceeded 2.3. The largest integer which does not exceed x, where x equal 2.3, where 2 is not exceeding 2.3. So step 2.3 can be written as 2. Here by observing 2.3 means 2 plus 0.3. In 2.3, we can write, so 2.3 not 2.03. So we can write this as 2 plus 0.3. So this 2 is known as the integral part. This 2 is known as the integral part. The 0.3 is known as the fractional part. This is known as the fractional part. So when writing a step function, we have to take the integral part only. So by taking 2.3, by taking step 2.3, where 2 is the integer and 0.3 is the fraction. 2 is the integer and 0.3 is the fraction. According to the definition, we have to take the integral part only. So sometimes in the step function, we have strictly integers. If you take 2.3, if you take 2.3, 2 is integer, 0.3 is the fraction. If you take x equal to 10, if you take x equal to 10, now step 10 can be taken as 10 only. So 10 means 10 plus something. 10 can be written as 10 plus 0, 10 plus 0, where 10 is the integer and 0 is the fraction. So step 10 can be written as 10. If you take the negative value, so like this, step minus 3.6, if you take step minus 3.6, okay. So step minus 3.6, we can write like this. So step of minus 3.6. Here if we take the integers, actually here minus 3.6 is there. When minus 3.6 is there, we can write that as minus 4. We have to consider the largest integer only. Here so many integers may be there. So minus 4, minus 5, minus 6, so on. But among all those, we have to take the largest integer, that is minus 4 only. So if you have the positive number like this, take exactly the integral part. If we have the integer only, that may be negative integer or positive integer. If we have like this, step minus 3, we can take that is minus 3 only. If we have a negative number like this, negative number like fractional part, integral part plus fractional part, then we have to take the number before minus 3.6, that is minus 4. If we have the number like this, minus 10.5, the number before minus 10.5 is minus 11. So if x belongs to R, then the largest integer which does not exceed x is called the integral part of x, and that is denoted by like this, and we can read that as step x. So these are the examples. So dear students, hope you understood the class today. So here just we have discussed the definition of step function only. In the next class, let us discuss the properties of greatest integer function, and also we can discuss the graph of the greatest integer function. So also we can discuss some more types of functions in the next class. So dear students, hope you understood the class today. So thank you for watching my class, and thank you for subscribing EdMaster. So thank you very much.